In the history of science, some names shine forever: Einstein, Darwin, Watson, and Crick. But alongside them are others whose roles were hidden, overlooked, sometimes even erased. One of those names belongs to a woman who captured the single most important image of the secret of life, an image that would lead to the discovery of the structure of DNA. Yet in her lifetime, she never received the credit she deserved. Her name was Rosalind Franklin, and this is her story. Rosalind was born on July 25, 1920, in London into a Jewish, well-educated, and comfortable family. From childhood, Rosalind was endlessly curious. She wanted to know, to test, to understand. At school, she excelled in every subject, especially mathematics and science. Teachers said she had a precision rare for a child. But Britain in the 1930s was not kind to women who wanted to become scientists. Most girls were expected to marry and raise families. Rosalind had other plans. She was determined to become a scientist. As a teenager, she attended St. Paul's Girls' School, one of the few schools that treated science seriously for girls. She thrived in mathematics and chemistry. When she went on to Newnham College, Cambridge, she was confronted with a harsh truth. Women were not granted full degrees at that time. They received only a certificate, not an official university diploma. But Rosalind didn't let barriers stop her. She buried herself in study and research. The path was clear. She would dedicate her life to discovery. She earned her doctorate studying coal and carbon. Dry subjects perhaps, but her work would soon prove crucial. During World War II, her findings improved gas mask filters, protecting countless soldiers and civilians. Colleagues quickly saw who she was: precise, relentless, serious. She trusted data, not speculation. She was already building the reputation that would follow her everywhere. After the war, Franklin moved to Paris. There she worked under Jacques Meringue and learned the technique that would define her career: X-ray diffraction. For the first time, she could use beams of X-rays to reveal the hidden architecture of molecules. A secret world, invisible to the human eye. Paris was also freer, more welcoming than London. For once, she felt taken seriously. She made friends, though her life was still dominated by work. In these years, Rosalind Franklin became more than a chemist. She became a scientist capable of unlocking the very secret of life. In 1951, Franklin returned to London to King's College. The atmosphere was formal, male-dominated, hierarchical. She was put in charge of the DNA project. With her student Raymond Gosling, she began systematic experiments. But her relationship with colleague Maurice Wilkins was tense. He saw her as an assistant. She saw herself, rightly, as an independent scientist. Meanwhile, in Cambridge, two young men were chasing the same goal: James Watson and Francis Crick. An invisible race was underway. Franklin pressed on with extraordinary care. She adjusted her equipment, refined her samples, and captured diffraction images of DNA. One image, known today as Photo 51, would enter history. It showed a distinct cross pattern, the unmistakable signature of a helix. But Franklin refused to jump to conclusions. She wanted every angle checked, every measurement confirmed. Watson and Crick, by contrast, were impatient. They wanted to build models, to leap ahead. And then, without her knowledge, Photo 51 was shown to Watson. In that instant, the path to the double helix was unlocked. Watson and Crick built their model, the double helix of DNA. In April 1953, their paper appeared in Nature. In the same issue, Franklin's own paper was published, important but overshadowed. The world heard the names Watson and Crick. Franklin's name was buried in the supporting material. She never publicly complained, but the truth was clear. Her data had been the key that opened the door for others. Afterward, Franklin left King's College. She joined Birkbeck College, where the environment was freer, more supportive. There she turned to viruses. She studied the tobacco mosaic virus and the polio virus. Once again, her images revealed hidden structures, shaping the foundations of modern virology. Those who worked with her remember her as demanding but inspiring. In the right environment, she was not just a lone worker, but a brilliant collaborator. But her life was to be short. In 1956, she was diagnosed with ovarian cancer. She underwent surgeries, endured chemotherapy. Yet even as her body weakened, her mind never stopped. From her hospital bed, she asked colleagues about results, about data, about progress. On April 16, 1958, Rosalind Franklin died. She was just 37 years old. 4 years later, in 1962, Watson, Crick, and Wilkins received the Nobel Prize. By then, Franklin was gone. The Nobel cannot be awarded posthumously. But even if she had lived, would her name have been included? We may never know. Today, Rosalind Franklin is remembered as she should be, a pioneer, a symbol of precision and courage. Her name graces universities, laboratories, and even a Mars rover. Her life was brief, but her impact eternal. Every time we speak of DNA, we echo her voice. the woman who gave us the image of life itself.